Before getting to the solution to option C, there is something I wanted to show you from A and B that I forgot to mention in the previous videos, and these are the most two common cases. So generally, once a series is given to you, it's either of this form, that is the sum from k equals to 1 to infinity of x raised to the power k all over k square, where you have to simplify x to the power k or any variable. And the second form is actually given a factorial. So in this case, you can be given a factorial, let's say k factorial divided by 2 raised to the power k, something like this. And just to quickly show you what they need to do, we are going to name our series of this to be ak, and then our other series will be let's say ak plus 1, right? Ak plus 1. So this will simply be k plus 1 factorial divided by 2 raised to the power k plus 1. So as we all know, this will simply be the limit as k tends to infinity of the absolute value of ak plus 1 divided by ak, and this will simply be k plus 1 factorial divided by 2 raised to the power k plus 1 multiplied by 2 raised to the power k all over k factorial. Now this is even a more interesting question, because there are two ways in which you can simplify. You can simplify the factorial, right? And we can also simplify our exponent. So to do that, we know that k factorial, right? K factorial, the k factorial of any function is the same as k multiplied by k minus 1, k minus 2, k minus 3, all that 3 to 1. You get the point? So in this case, what we have, right, is k factorial and k plus 1 factorial. So we need to consider one of these to simplify it to be similar or same as the other. And it's pretty much the same thing we used to do with 2 raised to the power k. We saw that here we can have 2 raised to the power k, so we can do the same thing here as well, right? Which is simply 2 raised to the power k multiplied by 2. So we have to do something similar to have either k factorial or k plus 1. We see that we can have k factorial from k plus 1, right? So k plus 1, all that factorial can be written as k plus 1 first, then k plus 1 minus 1, right? K plus 1 minus 2, k plus 1 minus 3, k plus 1 minus 4, right? You have to continue to infinity. But if you put this factorial here, this simply means you can continue, right? So this will simply be k plus 1 and k factorial. So from k plus 1 factorial can be written as k plus 1 multiplied by k factorial. So we can now substitute this above here. And substituting above here, we have k plus 1 multiplied by k factorial. Now divided by, we know that 2 raised to the power k plus 1 is 2 raised to the power k multiplied by 2. Then multiply by 2 raised to the power k all over k factorial. Now this will simplify this, and this will simplify this. We'll simply be left with the limit as k tends to infinity of k plus 1 all that divided by 2. And as k tends to infinity, this value will be infinity, which diverges because it is greater than 1. Good. So this was a very, very good example which actually demonstrates how you can simplify both an exponential function and a factorial function. So this is very, very important. These are the two common cases. So it's either something like this comes in the exam or something like the factorial comes. So yeah, that was it.